The broadcast is now starting. All attendees are in listen-only mode.
Good morning, ladies and gentlemen, or good afternoon, wherever you may be. Stay safe if you're in the North Carolina, South Carolina area. I'm right dead in the path of it, so we'll see how it comes out for us. I would thank Peter Shore today for coming in and speaking to us. I thank for each one of you for coming in. We will have this recorded up on YouTube. I would say normally by this weekend, but if I don't have power, I will get it up there as soon as I can. I will also will take questions throughout, and after each section, Peter will answer your questions. So if you have any, just post them in the question pane. Along with that, of course, we are a PASS virtualization group. The member of PASS, if you've never heard of it, of course, is their main event is coming up here in the 1st of November called PASS Summit. If you would like to go, just hit me up and I can give you a discount code for $150 off of PASS Summit. It's a great event in Seattle. There were about 30 of us, not 30 of us, about 4,000 of us actually go up there, and a lot of DBAs, a lot of learning, some partying and networking. So if you've never done it, also check out your local group. If you've got one in your area, of course, coming to the virtual group, you may not even have one close to you. So thanks again for attending, and I'll let Peter further introduce himself. Thank you.
Greetings. I almost said good afternoon, but like Tom, I'm in the Eastern time zone of the US and I have no idea where the rest of you are. So we'll just stick with greetings. As Tom said, I am Peter Shore, and this is an introduction to infrastructure for the DBA. The target audience of which is really folks who, unlike me, are not accidental DBAs. They came up from the infrastructure side. The target audience of this really kind of crystallized itself for me as I was working with some developers and some DBAs who'd come from the development side of the house. And now I also know some DBAs who have been in the BI, who even came from the finance side before that. And they just aren't familiar with the infrastructure side of what is under the database server. So that's what this is about. Before we get any further, about me, I work for a company called RDX. I'll tell you a little bit about them in a moment. I am what I call an intentionally accidental DBA, which means that if you look at my resume or my LinkedIn profile, it screams accidental DBA. The difference is I did it on purpose. I'm almost ready to change that to over 25 years of IT experience because I'm coming down with the OLD, and you can see what I've done prior to being a DBA. I'm the president of CBUS PASS here in Columbus, Ohio. So if you are somewhere near Columbus, Ohio, please check us out. Unfortunately, you missed our September meeting. It was yesterday. I also co-organize SQL Saturday Columbus, and you can see there how to find me. As I mentioned, I work for RDX, Remote Database Experts. We're a managed service provider. We can do, we primarily do SQL Server, but as you see, we do MySQL, Postgre, Oracle, DB2, a little bit of Windows, and we can provide monitoring, augment current staff, or if you happen to be in a situation where you're the accidental DBA and don't really want to be, we can be the DBA for you as well. If you have any questions about RDX, just email me, the pshore73@outlook.com address, and I will get in touch with you that way. Otherwise, I'm going to end the commercial and start the actual content. So before I get really any further, I just want to give a reminder that we're going to touch on a lot of aspects today. We all have brethren in our current IT departments or IT departments that we've worked in that have made a career out of each of these areas. And this presentation is by no means going to make you that degree of expert. The intent is really to allow you to be a little more familiar with some terms, maybe help you, if you're not used to the infrastructure side, define who you need to ask some questions of, and be able to talk their language a little bit.
Okay, looks like, ladies and gentlemen, we have lost audio with Peter. Let me see if I can raise him. Peter, are you there? Hey, Peter, are you there?
Can you hear me okay this way?
Yeah, you're back, Peter. I can hear you now.
Okay. Hopefully this is not too echoey because I switched over to the mic in the computer.
You're good.
So, okay. So short summary of the things I've said already is that this is a session intended to be an introduction. So we need to remember that the folks who work in these areas I'm going to talk about have made a career out of it. And the goal here is to allow us to understand what these components are, so you know who to ask questions of, and you can use some of the words and vocabulary that they're used to hearing to ask questions, so that it can be a more fruitful conversation for you. One of the side benefits along the way is you might pick up a couple of examples that you can use to explain something to some non-technical folks in your life, because we all know we have some of those. Local area networks. We're going to start with networks because everything needs to talk to each other. That's how applications get to the database. I suppose we could also argue without local area networks, our databases would be, much less complained about. But anyway, local area network is simple. It can, from a high level, we're going to use this in a limited area. Think about your house. If you work in a school, in an office, that's the kind of area we're going to see a local area network in. And we have WANs, which are wide area networks. Effectively, they connect multiple local area networks, multiple data centers, the most obvious example being the internet. And then we have VPNs, which I'm sure we all use, virtual private networks, and it's a tunnel. And you can literally think of it just like a tunnel of a highway through a mountain. It's an encrypted connection within the regular connection, so that we can communicate safely into a particular environment. You may hear the term VLAN, or Virtual Local Area Network. This is not actually a hypervisor term. It's really a networking level term to partition traffic, partition security. It allows the network staff to use something called QoS, quality of service, which what it's called is QoS tagging, and that allows them to give priority of a particular type of traffic over another. On the security front, the example that I like to give is here in Ohio, where I live. I've talked to some, and I'm in Columbus, which is the capital. I've talked to some folks who are networking people at the State House in downtown Columbus, and the Democrats and the Republicans are literally running on two different VLANs, so their traffic can't intersect with each other. An important thing to note, VLANs do not expand bandwidth. So if you've got a 1 gigabyte connection and you start putting VLANs on it, you get smaller
connection throughput, not a whole bunch of 1 gig capacity, concurrent capacity networks. Something we'll talk about here and a little bit when we get to storage is bandwidth versus latency. Bandwidth is the maximum throughput. So this is how much we can do at the beginning, how much traffic we can carry at an optimal situation. Latency is the delay from the input wherever the traffic gets on the network to where it gets off. If you want to think about this in terms of things you're familiar with, think about that highway that you drive on, whether it's to get to work, to go on vacation, or whatever. If it's 6 lanes, 3 in each direction, you have 3 lanes of bandwidth eastbound and 3 lanes of bandwidth westbound. The latency is how long it takes you to get from exit 1 where you want to get on to exit 5 where you want to get off. Communication over a network starts down at what's called a packet. It's a unit of data routed from an origin to a destination, and a packet is broken up into segments that talk about the content of the packet. They talk about the source and the destination. The biggest part is the payload, and depending on the protocol that's being used, there may be a cyclical redundancy check on the back end of the packet to make sure that the packet doesn't get corrupted. As you may start to guess, it takes a whole lot of packets to deliver even a very small message. The query that goes into SQL Server, it may be, select star from a table. And that still takes multiple packets to get in, and then of course the data coming back takes a whole lot of packets. We have network devices called switches. There used to be these things called hubs, but unless you've been around IT for a while, you've probably not seen them. And I've not been anywhere in a long time that even still has them. So other than mentioning that they used to exist, we're not going to talk about them. According to Cisco, and when it comes to network definitions, I'm okay with believing Cisco, switches create networks. And what a switch is, to visualize it, is it's a box that has multiple ports in it that you can plug network cables into. We can use them to connect clients to servers. Often when we're connecting clients to servers, we're connecting clients to a switch, to another switch, and maybe even to another switch into the servers. Servers to servers, and servers to storage, depending on the storage configuration. Switches come in managed and unmanaged. So what's that mean? Managed switches have an ability for us to see, us or a network manager, to see what's going on in that switch. Depending on the manufacturer, depends on exactly what we can tell and see what's going on, and also how we can configure it. Some are very minimally configurable, and some are quite elaborate, frankly. Unmanaged switches just sit there and move packets around. You are reading that correctly. You can get a switch as slow as 100 megabits per second, and there are now 100 gigabit per second switches out there. Here's hoping that someday soon we all have SQL servers connected to storage over 100 gigabit switches. One term that you will probably hear, or potentially hear, particularly since we're talking in the virtualization group, is a virtual switch. That is really nothing different than a logical implementation of this same physical switching concept. So there's nothing different there, except it's not physically there, just like when we virtualize a server. We have routers, and this is not the kind that come from Black & Decker or Craftsman or your favorite hardware manufacturer. These, again, come from places like Cisco and Juniper, and routers connect networks. So the internet is really made up of a bunch of routers talking to each other. And going back to the definition of a WAN, you need routers to build WANs. And all the router really does at a very high level is determine the next network point a packet should be forwarded to. What do I mean by that? You make a connection, you're trying to get out to the internet from wherever you are right now. The packets for this webinar are going out to a router on the edge of your network, and they're just going to the next router. They're using one of several different routing protocols and basically asking the question, hey, how do I get this packet to where it wants to go? And all of the protocols, in a basic and simple way, get down to what's the shortest and fastest way to get this particular packet to this particular destination. Yes, you can successfully infer from that statement that the first packet and the second packet may not take exactly the same route to the destination or back again. And that's okay, because the routing protocols, the communications protocols, which we're not really going to dive into today because those are a whole set of depth on their own, take care of making sure that entire message gets assembled properly when it gets to that destination. One of the protocols we are going to touch on briefly, though, is TCP/IP. Why are we going to touch on that one? Because that's kind of the default protocol that everybody uses these days. Back when I was a young IT person in the early 90s, I took Novell's Network Technologies test, which covered 7 or 8 different protocols in depth. It was horrible to try and take that test. TCP/IP is kind of the default standard these days because there's really nothing else in use. It was born out of the Department of Defense here in the United States, really in the late 60s. And it was in production in kind of a follow-up to DARPA, the ARPANET in 1983. It's what's called a connectionless protocol, which simply means that it sends the packet out and it doesn't keep that channel of communication open for the entire message. It sends the packet, closes it, packet gets there, and something comes back, as opposed to setting a static channel. You can see that there are a rather large number of addresses because it's a 32-bit address in 4 8-bit octets. You've all seen this: 10.1.1.1, 192.168.3.5. Those are common IP addresses. But even with, what's that, just shy of 4.3 billion unique addresses, we're running out. Why? Because according to recent estimates, there are about 3 billion, yes, that was billion with a B, smartphones and tablets in use in the world today. There are some things that are being done with the way IP4 v4 is classed that allows us to play games with that maximum number, kind of, but we are still running out of addresses, which is why IPv6 was implemented. I'll be honest, I've not used IPv6 anywhere. I've not seen it in use anywhere, though I understand after it being out now for about 10 years, it's finally starting to pick up some adoption. It's not interruptible with IPv4. It has a ridiculously large number of addresses. I'm not even going to try and expand that 3.4 times 10 to the 38th power, but it is in 8 groups of 4 hex digits, which is why we see, Fs and Ds and A's along with 1s and 2s and 3s in our IPv6 addresses if we're using it. TCP/IP is a protocol suite, so it has some services or applications, and I kind of throw some air quotes around that, just for what relative to what we think of as applications. Dynamic Host Configuration Protocol, DHCP, sure you've heard of this, and essentially what it does is automatically hands out IP addresses, the subnet mask, which allows us to break networks up in, or break TCP IP address blocks up into networks, and the default gateway, which is basically, hey, I don't know where this packet should go. I'm going to send it to the default gateway and let that figure it out. We can allocate static addresses through DHCP by aligning the MAC address, which is a unique address for each network card, in the DHCP management screen. And each address has a lease, which means eventually it times out. But almost always, if your DHCP lease times out and your machine is on, you just get the same address back. We have DNS, Domain Name Services, which we've all heard of because we use it every day. Even if you don't realize it, it's the phone book of the internet. Because I don't know about you, I have no capability, let alone interest or desire in remembering the IP address of every web server that I visit. DNS allows us to put a name in, something we understand, to our web browser or to our Windows Explorer browser or into our connection string. And through DNS, it will look up that name to an IP address that the computers can then process. We have a couple of different types of records. We have an A record, an address record. That's linked to a server, generally a canonical name, a CNAME referencer, which allows us to reference or do redirection. Yes, you can do redirection through DNS to an instance name from the SQL Server side, which can make upgrading hardware or migrating hardware much easier because we don't have to change connection strings and applications. And of note, the mail exchanger or MX record is what identifies a mail server. So every one of us has, there's a corporate MX record for your corporation's email server. And when we get to networks, we talk about wires versus radios. Wired networks have been around a long, long time. They're tier by tier, higher speed, more secure. They're fantastic for data centers where there tends to be a lot of interference anyway, and we want those higher speeds. But man, they're not so flexible, and the installation cost on them is high. Think about it. Every time you have to put a new network drop in out in the cube farm, you've got to put a hole in a wall, run some cable. It's expensive. Wireless, hey, they're flexible. We just have to run enough cable to get some access points up. We can do BIOD, bring your own device, which I suppose we could argue is also a con. And they're a relatively lower installation cost because we don't have to run as many wires, put as many holes in things. But they're slower tier by tier. The highest speed I'm aware of at this point for wireless networks is gigabit versus the 100 gigabit for wired. There are some serious security weaknesses. It's much, much easier to intercept packets on a wireless network than on wired, and they're highly susceptible to interference. We've all seen that with cell phone networks when we walk into a building that's got a lot of metal and concrete block. And at this point, I'm going to take a moment and see if there are any questions about the stuff on networking.
We have no questions yet, Peter.
Excellent. When we move on to server hardware, we can kind of interchange the terms servers, hosts, and blades, although it's not completely correct. And let me explain what I mean. Server is probably, at least in my view, the most generic of these. Host, I know in my vernacular, I use host almost exclusively when I'm talking about the physical part of a virtualized server farm. So the physical hardware the virtual server runs on. And a blade is a specific type of server hardware that goes into a chassis and has some specific characteristics and some advantages and disadvantages from a management and storage perspective. But a lot of times they'll also be, these terms will be used interchangeably to talk about the physical device that a server is running on. And this is where we're going to get into some things you may have heard of before. I just want to, and this is one of those level setting portions because there might be some folks who aren't comfortable. All of these things have probably more than one CPU at this point, or central processing unit, which is physical silicon, and in addition to some cache area on there, which is localized memory. They're largely made up of cores which handle the processing. They're the cores of a processor handle the processing of machine language instructions, because if you didn't know it, everything that we do breaks down to ones and zeros, and the cores of the processor do the stuff that needs to be done that way. We can, almost always do in these days, have hyper-threaded cores, which means that each core can do two things at once instead of one. Hyper-threading, in case anybody's wondering, is perfectly fine for SQL Server with modern processors and modern versions of Windows. And by modern, I really mean server, at least Server 2012, probably even Server 2008 and newer. So maybe modern is not the best word for that anymore. We have RAM, which stands for Random Access Memory. This is the key for SQL Server, right? The SQL Server will take all of the memory you give it unless you set the max memory amounts, and we all knew that part, but this is physical work area. It is directly attached to the processor sockets via the bus, which is the path of communication on the motherboard of the server. And we'll talk more about the implications of that in just a moment. Because we have a thing called NUMA, or non-uniform memory access. And what that means is in a multi-socket motherboard, so two or more, and it's really two or four, it's an even number, 6, 8. There is a bank of memory directly attached via that bus to each of those processor sockets. So that means a couple of things. Each node of memory is directly accessible by a CPU, and it is extremely costly to go across that inter-socket connection, which is why when we configure max degree of parallelism in SQL Server, we don't want to cross NUMA nodes because it's quite expensive to do so. I know VMware, I assume Hyper-V, but I don't know it for certain. I know VMware, if you set your max stop in your virtual machine, and the virtual machine, or I should say the virtual machine has a number of cores that are less than the number of cores in a single processor, the hypervisor layer will consolidate them onto a single physical processor, regardless of how you have that set up in terms of virtual CPU. So that helps with a new management at the physical level. It also means if you happen to have a server that has processor sockets that you're not using, don't put memory in those banks because you won't be able to get to it. All right, you're now all going, when did we go to the kitchen demonstration? But I want you to kind of hang with me here for a moment. This is one of those moments where we're going to kind of crystallize some things in people's heads. And also, this is another one of those examples that you can, talk to somebody non-technical with. We've all at least been in a kitchen, and we've all at least watched somebody cook. Probably many of us do cooking on our own. So if you look around the kitchen, those cabinets are storage. Duh. Well, that's kind of similar to disk storage in our computer. The counter is RAM. That's where we're working with the things that we've pulled out of storage. What's missing from this picture? The CPU. The CPU is you, the cook. All right, so think of an old school single core processor in these terms. You are the cook and you are cooking with one hand. That is an allegory to, or analogous to, a single core processor. To be a dual core processor, you now use your second hand. We are going to assume that we can do things independently and equally well with each hand. I don't know about you, but that's not necessarily my strength in the kitchen. But if we can, and now if we were able to do two things at a time with each hand, we would be hyper-threaded. Yes, that's the biggest stretch in this example. But hopefully that kind of helps to solidify for you exactly the difference between memory and storage and processor. So again, the storage is the cabinets. We pull things out, put on the counter. It's RAM. It's our temporary storage, our working storage. And you're the CPU processing things, doing things. And the number of hands you're using is roughly analogous to cores. Any questions on the CPU and memory piece before I jump into a little bit of storage?
Yeah, we've got one question here. Would physical cores be equal to cores and hyperthreading equal to logical cores?
At the physical machine level, yes. It gets a little more complex when you add the hypervisor level to it, because really all of the virtual CPU and virtual cores at that point are at least theoretically logical. But if you're just looking at it from a physical perspective, to the best of my knowledge, cores are physical threads and hyperthreads would be logical. Any other questions?
One other.
Sure.
Should AWE memory be used?
No, that has been, from a SQL Server perspective, deprecated since, I believe, SQL Server 2005. And if it's not 2005, it's 2008. And I know I'm pretty sure the option went away in 2012. So AWE memory is just a process by which you can effectively fake out a 32-bit operating system and a 32-bit instance of SQL Server to use more than the maximum 4 gig of RAM that a 32-bit OS can address. At this point, you should be using 64-bit OS and 64-bit versions of SQL Server, and AWE really doesn't come into play that much in modern OSs and modern versions of SQL. If you're using older ones that are having that restriction, my honest answer is you need an upgrade path. You need an upgrade path fast, because all those versions are no longer supported by Microsoft. Just like SQL Server 2008 R2 go end of life on July 9th, 2019. And Windows Server 2008 R2 and Windows 7 on the desktop, by the way, go end of life on January 14th, 2020. Any other questions?
Nope, that's all.
All right, so moving on to storage, because as we all know, RAM is volatile. When we reboot the server, we lose everything there. We need to have some place to store this. So we can store it locally, which is directly connected to the server. And this can be either physically in the server or in a chassis that is directly attached. The controller is typically in the server at that point. The disk is most likely in the server, and it's best configured at server level. Yes, you can configure software level RAID, but you pay some performance penalties for that. RAID stands for Redundant Array of Inexpensive Disks, and we see a couple of common RAID levels here. RAID 0, you stripe it, no parity. You pay some write penalty for that. Mirrors or RAID 1, you pay heavy write penalty for because you write it to disk A, and it also has to write to disk B. RAID 5, striping with parity. You can survive a bigger disk deficit. You can survive a failure in this one much easier because they're striped across disks. You have to have at least 3 physical disks. In all of these, if the disks are not of equal size, you get to use the amount of storage on the smallest one is the most any of those other disks can use. So if you're going to mirror a 500 gig and a 1 terabyte drive, just go buy another terabyte drive because you're going to lose 500 gig of that terabyte drive in the mirror anyway. And no, you can't use it for something else. RAID 5 allows single disk failure, as does mirroring, and be able to survive it. RAID 5 is fantastic for reads, and it's another one where you pay a write penalty. And by write penalty, I mean writes are slower. RAID 10 is a mirror of stripes. You effectively lose in the RAID 10 configuration 2 disks worth of storage, and you have to have a minimum of 4 physical disks. In RAID 5, you have to have a minimum of 3 physical disks, and you effectively lose the capacity of 1. So a RAID 5 with 3 1 terabyte drives would give you 2 terabytes of storage. RAID 10 with 4 1 terabyte drives would give you the same 2 terabytes of storage. RAID 10, you do not pay a write penalty. Reads and writes are effectively equal in that configuration. Some people refer to RAID 10 as RAID 1 plus 0. Yeah, okay, technically, because it's a mirror of stripes. And there is such a thing as RAID 0 plus 1, and they really talk about the order of whether the data is mirrored first, then striped, or striped first, then mirrored. And I'll be honest, I forget which one is which, because it's more trivial knowledge at that point than practical knowledge. We also have PCIe cards. This slot really came to my attention in PCs about almost 20 years ago because it was the place all the gamers put the video cards because it was faster. Because it's a slot on the motherboard, it's directly on the bus. Most common uses for this from a storage scenario are PCIe flash disk cards, the old SanDisk Fusion IO cards, which were very expensive. There are now a lot of competitors for that out there, but that's just a sample. So you've got flash disks on the bus, which are much faster. A couple of things to note that I should admittedly add to this presentation. There is M2 storage, which is another type of directly attached flash storage on the motherboard. And I forget the proper name for it, but there's effectively disk storage now on the RAM chips. So it's flash type disk on the RAM chips. So it's that much faster because it's on that same bus. But there are a lot of limitations to it. It's very new technology. So it's limited, and new also means it's what? Expensive. But it is out there if you need that kind of speed. So we've talked a little bit about how direct attached storage works. It's either, it's a physical connection, whether it's a chassis, another thing in the rack, used to augment the local storage, and it's generally external to the physical server. We have NAS, or network attached storage, often goes through at an enterprise level, what's called a NAS head that'll control access to multiple NAS devices. You may have some type of NAS at home. I know Western Digital makes some NAS. and there's Synology that makes some very nice NAS devices that are people use at home, or at least people I talk to. Maybe I just talk to some deeper nerd types that use some of the higher grade equipment at home. The server connects over network traffic. This would be a place where we talked about quality of service, or if you're using network attached storage, you might want to talk to your network team about having some quality tagging so storage gets priority over the network, or it being routed on its own separate IP space and its own separate physical network. We've all heard of SANs, storage attached networks. They can be connected over iSCSI across the LAN. Again, you have all those things I just said about NAS and QoS supply, or fiber channel. Fiber channel is a storage connection medium. It's its own type of networking. A note about that type of storage is that the entire fabric of fiber channel will work at the speed of the single slowest device. So if you've got a 2 gigabit connection in your fiber network and everything else is 16, you're going to run at 2, regardless of whether your traffic is actually going across that 2 gigabit or not. So that is something to be aware of. And because of this connection type, particularly if you're using fiber channel, it behaves a little bit more like onboard storage. Both NAS and SAN can be used with traditional profile servers, whether they're rack mount or tower, or with the blades I mentioned before. One of the things about blades is they don't have very much capacity for physical storage, generally just enough to boot them, if at all. You can actually boot off of attached storage if configured properly. One thing I always tell clients about storage, whether you're using NAS or SAN, configure it for SQL Server exactly the way the vendor wants you to configure it, whether you agree with them or not. My reasoning for this is, when you eventually have to call them for support because they're too slow, if you're not configured to their specifications, they're going to say, okay, before we can help you, you need to reconfigure to our specifications, which means you're going to have to incur an outage to reconfigure. You're going to have to retest, reprove the performance issue, and call them again before they will engage to actually help you. If you just configure it the way they said to in the first place, it will allow you to skip all of that and you can start fixing the problem right away. Occasionally, by the way, you will see a piece of software that comes with a database component that will advise how you should configure the disk for the SQL Server underneath it. And by occasionally, I mean the only one I've actually seen that has this in the documentation is SolarWinds Orion. And at least for locally attached storage, it's a beast. At least it was 5 or 6 years ago. To get what they wanted would have taken something like 22 or 24 physical disks. So I had to play with that because I didn't have that to deal with. But if there's a software vendor that has recommendations for storage, I can't say I always follow those because I don't necessarily trust them as much. By the way, I don't necessarily trust all the SAN vendors either, but I'm going to trust them more than a software vendor. I apologize if I've offended a software vendor on the call, but that's just the way I think about it. Your mileage may vary. When we're talking about storage, just like when we're talking about networks, latency is a critical metric. You will often have SAN admins talk about IOPS, input-output operations per second. And there's usually a big number that goes along with those, which is fantastic. We like big numbers in IOPS because it's processing that many more operations per second. but you have to push them past looking at the IOPS and look at the latency to make sure that there's no latency under the IOPS, or that there's queue depth issues or things of that nature when we start talking about the storage. All right, any questions about storage?
Yeah, we've got a couple questions here.
All right.
Could a PCIe be used for temp DB?
That is actually one of the great use cases for it.
Okay.
Just remember, there's no redundancy for it typically. So take that into account, because if you lose temp DB, your whole instance is done.
All right. With the new flash technology and storage, vendors recommend that we don't need to create new drives separately for data or logs. Is there anything you can add to that?
That is a piece of the storage puzzle that I admit I'm still working out and debating, because when you start getting, whether we're talking physical spinning rust or we're talking flash storage, all those drives are in the same box, in the same physical box. They're they may, depending on how they're allocated, you may, despite lopping off a slice here and a slice there for databases and logs, they may not actually be on different physical media, which is what the original intent of that was, because of the random reads of the database files versus the sequential reads of the transaction log files in spinning media. So I'm still researching that one. And at some point, I hope to actually get an answer. I'm hoping to sit down with a couple people at Summit to really get my head around that one. So you may want to ping me in a month and a half to see if I've come up with a better answer to that one now. And I'm sorry that I don't have a great answer for it at the moment.
Yeah, that might be a good one for you, a blog post, when you get back to mention that.
Yeah.
There's a lot of people that now have that question, of course, with new flash SSDs, stuff. So one point that someone made, if you need to move to another system, you may need different drives. Not sure how that would help. I know I'm building a new database system now that we're still using, or we're using file groups and files to help us possibly alleviate hotspots if we needed to move it around. So I'm kind of wondering if that's even still required or needed. So
yeah, that's a good question too, because the flash really does change how that works. And from what I know, and it's very little about some of the flash storage solutions, it also depends on how that flash solution is implemented from the vendor.
Yeah. All right, that's all. See.
Alrighty, so finally we're up to the title of this group, virtualization. I'm sure you've all been on calls before with this group that have said effectively this: hey, guess what? Almost all the SQL Server workloads can be virtualized, assuming that the hardware underneath that's hosting the VM farm is capable of handling it, and that the hypervisor and the VMs are properly configured. If you're using VMware, a new or an updated version of the how to configure VMware for SQL Server white paper dropped yesterday. So read that, check that. That's what I would tell you to do to get to the must be properly configured piece. Read that. And I will say that I trust it immediately, because two of the biggest contributors to the white paper outside of VMware were a couple of folks who have been around this group, David Klee and Alan Hurt. So those are two guys I really trust when it comes to virtualizing SQL Server, and they have had significant contribution to this white paper from VMware. Somebody's asked me about Hyper-V. I'm sure there's a similar paper for Hyper-V. I've just not been in a position to deal with it, so I don't have an explicit answer for you on that one. What happens when we virtualize a server is the hypervisor creates an abstraction layer between the server OS, Windows Server most likely, although it could be Linux these days for a SQL Server, and the physical hardware. So the virtualization layer is controls the access, manages the access to that hardware. Windows thinks it is because it controls the access to what it thinks is the hardware, but it's really the virtual hardware. And then those drivers control the access to the actual physical hardware. You could have host level memory pressure. In VMware, you're going to see balloon drivers coming into your service, into your running tasks. If you see that, that's not a good sign at all. So it means that host has memory pressure and it's trying to steal from your SQL Server to use something else, to give that memory to something else. There is some documentation from VMware in that white paper that I referenced about how some of the counters, particularly the active memory counter in vSphere, are not valid for SQL Server because of the way it measures active memory. I don't completely agree with that statement because I feel if the active memory counter is showing your SQL Server has high active memory, you've got a problem with your SQL Server and it probably needs more memory. A VM admin who is not familiar with running SQL Server in VMware will likely tell you that if it is a low active memory counter, you have too much memory. That's the piece that VMware acknowledges is not correct. Virtualization is a viable part of a high availability solution, but it's not the whole thing. If for no other reason that just because VMware will spin that server back up after a node crashes, it then has to go all the way through It has to go through the process of figuring out what was on that VM, bringing it up on on that host, bringing it up on another host. Your SQL Server then has to go through crash recovery before it can come back and be online and ready for your applications. So that's great as a piece, but you really want to consider other types of HA along with that, whether it be availability groups, FCIs, dare I say it, replication or log shipping. Just figure out what your needs are. The approach to backing up can be an issue because we have the ability to snapshot VMs. Unfortunately, snapshotting VMs freezes I/O. When we freeze I/O, that's a problem for our SQL servers. This is where, if you're on Twitter, the great debate between Alan Hurt and Veeam kind of sits, is in this space. So be aware. What I've done in many cases to avoid that issue where they want to do snapshots of the machine state is I get the VM admin to exclude all the drives that my databases and transaction logs are on, and they just snapshot the C and the D drive. And then I do regular backups of my SQL Server data out of that, and that kind of gives me a way around that problem. I'm going to kind of push through here because we're running short on time. The cloud is really just someone else's data center. And particularly when we're talking about IaaS, the infrastructure service piece, that's really just the same thing conceptually, but somewhere else. It's at a different data center. One thing I want to say about the cloud, whether we're looking at infrastructure service, platform as a service, or software as a service, it's probably more secure than your data center. Microsoft and Amazon have put a lot of money into these data centers, and they literally cannot financially afford a security breach because it will cause the loss of trust of clients if they're breached at the level that they control. and it'll cause them to lose money, probably in the case of Microsoft, go out of business. Amazon, I assume, could always fall back on that little retail thing they do. And they're very aggressive about patching on all these things. You, in an IaaS world, do own the patching of those VMs. Microsoft does not. Microsoft will take care of the infrastructure. And a platform as a service piece, Microsoft will take care of the patching. I'm going to talk Microsoft on that because I deal with it more than I do AWS. And as you can see, with infrastructure as a service, you can replace most or all of the infrastructure. From a server level, obviously, you still need connectivity. There may be reasons you still need some servers locally, depending on performance issues of particular apps and such. Platform as a service replaces backend systems. Think Azure SQL DB, Azure Managed Instance, Cosmos DB. Those are all backend services. A lot of the backend BI services, and it can minimize the complexity of an infrastructure and add some complexity. And it does not replace all of the on-site infrastructure. Software as a service is that broad range of productivity software. And let's be honest, as soon as Office 365 came online, Microsoft won in the software as a service perspective. One note about the cloud, you've all, I'm sure, heard about the South Central Data Center and VSTS problems that Microsoft had recently. If you are in an environment where it is important for someone in the management chain to be able to come and scream, yell, rant, and rave and get perceived results from someone in the IT department, that is a challenge for you in the cloud. And also, if you're trying to sell the cloud as less expensive, you have to be very, very, very detailed in your accounting for data center costs to make that cost argument work. Scalability, capital investment perspectives, there are great arguments for the cloud. I just want you to be aware that there are some things that you have to look at differently from that perspective. This is not the perfect analogy, but it's good enough to give you the concept. I would love to give credit to whoever did this, but I've seen it in so many places, I have no idea who actually gave credit, who actually came up with the original pizza as a service. And essentially what this does is break the cloud offerings down into something that we're all used to. At least in the US, we're all used to pizza. And I don't need to explain the slide. You can see it. It's rather self-explanatory. The blue stuff you manage, the green stuff the vendor manages. So depending on what level of things you have to do, or really defines what piece of the cloud you're in. So as a service, this is another way to look at it. And what's hosted in the cloud. This is a Microsoft, a piece of a Microsoft slide for that. This is just another way to visualize it. I want to mention quickly Active Directory, which is Microsoft's implementation of the Lightweight Directory Access Protocol. It is a database, believe it or not. It's hierarchical. It's not relational, but it is a database. Objects are organized by organizational units. I highly advise SQL servers to be in their own OU so that specific policies can be applied just to the SQL servers. I would group service accounts. I would look into if you're using SQL Server 2014 or 2012 or 2014 managed service accounts for individual standalone instances. And I would look into group managed service accounts if you're using 2016 or 2017 when we start getting into failover clusters and availability groups. Those are basically accounts where the password can change every 30 days without you restarting the service. So it's a nice security feature, and no one ever actually knows what that password is. Group policy is a way for you to configure, for things to be configured on a machine to limit or configure or allow things. You can use group policy to configure things like power policy, perform volume maintenance, and lock pages in memory. And those are reasons why you might want to put your SQL servers in their own group, because you might only want to apply those policies at that particular OU. Here we go, managed service accounts and group managed service accounts. I got ahead of myself. You have to have AD 2008 R2 functional levels or higher. It does use SPNs, but so does everything else these days. And I mentioned the group managed service accounts. The key difference is the managed service accounts for computer-specific. Group managed service accounts can be used on multiple hosts. I know I'm running over a little bit. We can also extend Active Directory to the cloud with ADFS, Active Directory Federation Services, and Azure Active Directory. It is also possible to extend to AWS, and then you have then you can use your on-prem Active Directory structure to manage access to various pieces of the cloud. The key thing about Windows Server is the TCP chimney offload. Microsoft seems to love to change what the default is for this. The short version, disable it because it causes connectivity problems. It was designed for connections that run the exact opposite way of the way SQL Server runs. You're all familiar with local policies such as lock pages in memory, perform volume maintenance as part of good practices for SQL Server, although there are some debates on the lock pages in memory that can be had. GP result/R will show you what group policies are in effect. That works on both servers and workstations. So if you want to know how you're being restricted, you can check that. There are valid arguments on both sides of using antivirus. If you're using it, make sure your AV admins have the proper exceptions in place. Microsoft has a great article that lists the exceptions that need to be in place for all of their products, not just SQL Server. And with that, I know I'm a couple of minutes over. Sorry. We can jump over to some questions if anybody has any.
I've got a couple out there that we can answer right quick. One of them is, can we get a link to the white paper that was mentioned? Maybe you can email it to me, and I'll just get it up there. Yeah. When I put the YouTube up there, I can put it up there. They could have it.
Yep, I can absolutely do that.
Okay, and then the other one, can you explain RAM versus virtual memory, and how do you troubleshoot it if you get alarms on virtual memory?
Virtual memory, it's been a while since I've explained virtual memory. Virtual memory to me comes back to the page file where Windows, typically Windows, is swapping memory out to a space on disk. So if you're getting virtual memory pressure, a bunch of stuff is being switched out to memory on disk or onto a file on disk, and that file is generally set to auto grow and be system managed. And you can either be running out of space for it on the disk, or you've got a hard cap on it if you've decided not to have it system managed, and it can be running out of space. And this is where we get into the lock pages in memory debate, because if we lock pages in memory with the SQL service account, none of the SQL information is being swapped out to disk, which means it's in the faster actual RAM, because RAM is orders of magnitude faster. But RAM is the literal physical memory chips that are in the computer or in the server that are directly through those slots that they're plugged into, directly attached to the bus and to the processor. Accessing virtual memory has to happen through the bus to the disk controller to the disk. And even SSD and flash is significantly slower than physical RAM. Next question.
That is it. That's all the questions today.
All righty.
All right. Well, go ahead, Pete.
I was going to say thank you to everybody, and thank you to Tom and the group for having me.
All right. Well, we appreciate you coming by today. And once again, ladies and gentlemen, I will have this posted I'll try to get it posted as quick as I can, but if I do lose my electricity, then it may be a little bit later. Watch for an email from it. And Peter, I'll see you in a few weeks in Seattle, and hopefully any of you other guys, please come on up and see us. It's a great, great time and great learning at PASS Summit here in just about the first week of November.
Yep, I'll see you then, Tom.
All right, thanks again. Talk to you later.
Thanks.
Bye-bye.
Bye-bye.